Hello and welcome to my presentation about CANOpen protocol. CANOpen is a communication protocol and device profile specification for embedded systems used in automation. The basics of CANOpen device are given in CIA 301 specification released by CAN in automation. In terms of OSI layers, protocol is defined in 7 layers compared to standard CAN, which has 2. The devices are connected to star connection, where each device is specified as a node and must be terminated by terminal resistors of specific impedance. A priority of each device is given by a priority of message the device requires to send. There is no universal master or slave device, such in case of SPI bus. There is no clock, so devices must be synchronized by a synchronization message. But let's start from the lowest layers, which are same for both CAN and CANOpen. Layer number 1 is a physical layer. In this picture, there is a comparison between single-ended and differential signals. As you can see, in the case of single-ended signal, the logic is given by a voltage of one single signal. Level 0 is usually 0 volts and level 1 is higher voltage. In case of differential signal, the logic is also coded by polarity of a voltage between two lines. These two lines are called CAN high and CAN low. If there is no difference, we call it a recessive signal and corresponds to logic 1, and the voltage difference is called dominant signal and corresponds to logic 0. In practice, it is always needed to have the devices connected to a common ground. It is also needed to have a CAN transceiver connected to the MCU, because MCU cannot generate differential signals. The MCU lines are often called RX and TX, but it's not a rule. For example, the Raspberry Pi uses SPI bus to connect to its transceiver. Let's now look at the arbitration. The device wins communication if it wins bus arbitration. This occurs when sending an arbitration field, which will be discussed later. For a device to win the bus, it must stay dominant when other devices are recessive. For example, if device A is recessive at the third bit, it loses arbitration and must wait for another turn. Layer number 2 is a data layer, as illustrated in this picture. It begins with the start of the frame sequence, followed by an arbitration field which carries a message identifier. So, as told before, the device with the highest priority of a message wins the arbitration. Then it follows a remote transmission field, signaling if it's a data frame or remote request frame. Then we have a data length code, which determines the length of a data field. Next field is a data field, followed by an cycling redundancy check, acknowledge field, and end of a frame field. Sometimes an extended frames are used. Compared to the basic frames, they have two identifier fields and ID extension set to 1. Some message IDs are combined with a node ID and together they form COP ID. In case of zero value of node ID, the message is a broadcast to all devices are based on services. Each device has a set of services it provides for other devices. These services are network management, emergency, synchronization, heartbeat, service data objects, receive and transmit process data objects, and timestamp. Client or clients send responses. We are also speaking about producer-consumer dependency in case of a heartbeat message. One device could be a producer and a consumer of the message consequently. This is the case of heartbeat, emergency, and synchronization objects. Services are distinguished by IDs, which specify a priority of a message. The ID of a message must fit into a range for this message, as seen in this picture. Now I will present a short introduction to Object Dictionary and will talk about it more later. For devices to handle information, they use Object Dictionary. It contains a list of items with read and write permissions. You can imagine each object in the Object Dictionary as a mailbox and the Object Dictionary itself as the mailboxes inside of a block of flats and services as inhabitant of the block of flats. As each inhabitant could open only his letterbox, so services can also access only their own objects. The objects in the Object Dictionary are sorted by its indices. Each service can reach specific range of indices which belongs to the service. More about services will follow in the next video.